Hi, welcome to the section of MapReduce. In this section, we'll be discussing how to write a MapReduce code for your word count example. Okay, I'll just give the explanation of each of the code in this example, and in our next video, we'll look at how to create a jar file combining all these Java codes and how to execute them in your local file system. First of all, let's look at what are all the features that are imported for my mapper code. First thing is I'm importing something called java.io.io exception. This input output exception is basically required to ensure that the input file which you are passing as your parameter is present, and also to ensure that the output path which you are passing as an argument is a new one and which is not existing. Okay, if it is existing path, then it should throw an error, or if your input file is not existing, it should throw an error. That's the reason why we are importing IO exception. And we are importing something called int writable, long writable, and text. These are nothing but your input, data types, or input and output data types. When you look at something called int writable is something which is similar to int data type in Java. So the question is, when you have already int data type available in Java, what is the point of using int writable, right? In Hadoop, we are gonna use larger data sets, okay, which should be in petabytes or zettabytes. So in order to handle that huge data, we have customized our data types to make sure that they are handling such huge data types. That's why Hadoop provides some inbuilt data types to Hadoop, like int writable, long writable, and text. Int writable is something which is similar to int data type in Java. Long writable is something which is similar to long data type in Java, and text is something which is similar to string in Java. Right? We are importing something called MapReduce base, okay, which is my superclass from where we are extending the properties. Okay, we'll see that while we are discussing about the code. We are importing also something called mapper, which is an interface. Okay, and apart from that, we are importing something called output collector and reporter. Output collector is something which collects your output, and it securely transfers that as an input to the reducer, because your output of your mapper should be passed as an input to the reducer, right? That job will be done by your output collector. Okay, we have something called reporter, which reports the failure of your mappers. Okay, if your mapper abruptly stops working, then the reporter is the one which shows what is the error of your mapper, what is the error due to which your mapper had stopped working. Now, we have something called the class name, which is called word mapper, which we are declaring here, and we are extending something called MapReduce base, which is by superclass, and implementing a mapper. And we are passing something like long writable comma text, which is my input. We already discussed while we are discussing about MapReduce architecture, like we are passing the input to the mapper like an offset address comma text. Offset address is nothing but the starting and ending address of your block, and the next parameter would be your block of content, or the actual content of data. So long writable will always signify your block address or your offset address, and text, which is of string, which is similar to string, will always point to your data or block of data. And once we pass this as an input to the mapper, the output of the mapper would be word comma 1. Okay, word is nothing but your text, and 1 is nothing but your int writable. So this is what we had discussed in our MapReduce architecture. You will be passing offset address and the actual content as an input to the mapper, and the output of the mapper would be some key value pairs. So your key value pairs are nothing but text comma int writable. In case of word count example, the output would be word comma 1. So the first two are inputs and next two are outputs. Now let's look at how to derive an map method. We have something called map method, and it will name your offset address as your key and your actual content as your value, and it collects the text which is your word and one which is iterable using output collector. Like I said, output collector is something which collects the output of the mapper and delivers that as an input to the reducer. Right? We have something called reporter, and which is like something like we have discussed, like reporter is something which reports the failures of your mappers, and it throws IO exception. So once we pass your input, the block of contents, as an input to your mapper, the first thing it would do is to convert your block of content into string. So we are doing that using toString method, which is inbuilt to Java, and storing that into a variable called s, which is of type string, and we are breaking this particular string into words. Right? That's what we do. Once we get the block of content, we convert that into string, and then we break them into words, and simply once we break them into words, we'll append an 1. Right? So once the word length is greater than 0, we are simply appending word comma 1. We are simply appending a 1 to each of the word. When I pass hello world as an input to my mapper, the output would be hello comma 1, world comma 1. How do we get that? That's what we had discussed. Using this word, then using this code, you will be getting a word comma 1. So this is how we'll arrive at a mapper logic. Now let's discuss about how does a reducer logic can be written. Like I discussed about a mapper code, even for reducer, you'll import few things like IO exception, okay, your data types, iterable and text, and your output collector, MapReduce base, reporter, and like we imported mapper, we are importing something called reducer here. Right? And then we are importing something called iterator, which is a Java utility. So we'll see the usage of iterator when we encounter that in our code. Okay, even the declaration of reducer would be same. Public class reducer, which extends MapReduce base and implements an interface called reducer, which accepts 2 inputs and which delivers 2 outputs. So my input is nothing but the output of the mapper, which is word comma 1. Right? So we'll get a list of key value pairs as an output of the mapper, and grouping the key, we will be summing up the values. We are hold the key and sum up the values, and so the output of the mapper would be word comma your final count, which is again text comma iterable. That's why we are declaring something like text comma iterable here. Right? And then we have something called your reduce method. Like we discussed, it will take text as a key and the values as your the output, the iterable as your values. It will store into that, but we are using something called iterator, because when I pass hello world as an input to my mapper, the output would be hello comma 1, world comma 1, hello comma 1, world comma 1. Right? So the final output of the reducer would be hello comma 2 and world comma 2. Right? So what did I do that? In order to sum up the values of a word hello, I have iterated through each of the value and summed up all the values. So how do you iterate? Using your Java inbuilt utility called iterator. It iterates through the values for a particular key, and we'll write some logic to sum up the values. Okay, and once we get the final result, we'll collect it using output collector, and we have something called reporter, which reports the failures, and which we throw something called IO exception. Yeah? And we are declaring a variable called word count, which is initially 0, and we have a while loop which iterates through each and every value for a particular key and sums up those values, and it will store that final value into a variable called word count. And finally, we'll print our reducer output as your key comma iterable of word, which is nothing but word comma iterable of word count, which is nothing but your word comma actual count. hello comma 2 world comma 2. So how do we get that? We are summing up using our while loop here. As simple as that. But after discussing about your mapper code and reducer code, we have something called your word count, which is your actual code or the driver code, which has the actual content inside it. I mean, the actual content means the quantity that is required to execute your mapper code and reducer code. So we are importing few things here. So what we'll do is, now that we know how to write a mapper code and how to write a reducer code, in our next video we'll discuss about how to write your driver code and how to create a jar file and how to execute that. Yeah. Thanks for watching this video, and bye bye.